Hi everyone, welcome back. Here we go with equations. I'm not on this one doing the very basics, that will be on another video. Let's have a look at what we've got. X means it stands in place of a number. I keep thinking back to primary school. Between the 2 and the X, a long time ago, a commission of people in Europe got together and standardised things, and one of the things they standardised about 250 years ago, I think, was that when you write two things together other than two numbers, it means there's a multiply in between. So we know there's a multiply there. We also know there's a multiply there. And people get confused on algebra because they don't know the basic rules or don't really understand why. If you're in primary school, we could have written 2 times the box plus 1 equals 7. I always like to do this to people. I'm thinking of a number, I multiply it by 2, and then I add 1 to it, and I get 7. It's good fun with the class and have fun, and people have to guess it, especially if I have rewards or lollies or something. So let's have a look at it. I'm thinking of a number, when I double it and I add 1, I get 7. There's a lot of people out there just do this. And we're going to take off the one that's 6. 2 what's a 6, and the answer's 3. So in primary school you can do that. When you get to this one over here, it's harder. And when we get to equations further on, my goodness, this is the simplest that we can possibly do, and the method goes harder. I've had students over the years who 2-3 years later finally said, Mr. P, please go back to the basics and teach me all over again. And I even had arguments with them sometimes, or just this tension all the time. I don't need to do that. I can do it in my head. So I'm pleading with you. After a lot of years teaching, I still plead with people, try to accept this and look at what it is. And once you get the hang of it, the whole purpose is so you can shortcut later. So what's the people who don't do it? In the end, a lot of people struggle to shortcut. There's going to be people watching it just know how to shortcut. It's too easy. But what's legitimate shortcuts when the question gets harder. So let's learn the methods so you can do the harder questions later on. I always talk about obs. We want to do the opposite to both sides. And I can't stop talking about it's like a seesaw. We've got to balance up the seesaw, or we've got to balance up the scales. If I had one kid on this, if I had 2 kids on this side and 2 kids and they're all about the same weight, and one kid hops off, the seesaw goes. So one kid hops this side and they balance up again. You might have to adjust it a little bit because we're not exactly the same weight. So if I remove 1 from the left hand side of the equals, that's from the left hand side, I remove 1 from that side. How do I balance up the seesaw? How do I balance up the scales? I take 1 from that side. Because some people don't like to put the -1 there. When I was at school, I was not allowed to write the -1 there. I had to write a separate line of working out. Some people think that gets confusing. I just don't find it. Occasionally I might find a student and I might then show them a little bit more about it. So what is a 1 take a 1? It's gone. So look at the idea of what we're doing. The 1 was there, now it's not. So we made this left hand side simpler. The whole goal is to get, it's right in red, X by itself. I want this, even though I know the answer to this one, to say to me the answer is a method we learn using in math on simple things, on very obvious questions, so we can do it on the harder things. Accepting that's big. 7 take 1 is just 6. What's between the 2 and the X is a multiply. I want to do the opposites of both sides. If I half this side, I half this side. A lot of people can just write X equals 3, but the method is so much more important. So what's the opposite of divide by 2? Divide by 2. I could write divide 2 that way, but it's much slower than writing that one there. And when you get to more complicated equations, you just can't put the divide in. It's much easier to go a fraction by. So I divide that side by 2, I divide that side by 2. How many times does 2 go into 2? Once, so I can write 1x. 2 into 6 goes 3, so what we're really doing, 2 into 2 goes once, 2 into 6 goes 3. Most of the time we just cross them out. Doesn't mean they're gone, it means they've become a 1. So they don't have to write the 1. So now a little bit faster in the process. What's it? Oh, and it tells us what we already knew was true. How do I get rid of -1 this time? Opposites both sides. Opposite of -1 is +1. You might notice that the number by itself is what I'm doing first all the time. I could get rid of the times by 3 first, but we'll leave that for later videos. For the moment I want a habit. We're creatures of habit, want to do it the same way all the time. If I add 1 to this side, add 1 that side, to balance the scales up. So now I'm left with a 3x. Nice part is, this is now less complicated than what it was before. 11 plus 1 is 12. Now I've got to multiply between the 3 and the x. How do I get rid of a times by 3? I divide this side by 3. I divide that side by 3. So now we go 3 into 3 is 1. I don't have to write these 1. Can cross them off if I wanted to. How many times is 3 going to 12? It's 4. So method works. Could you have guessed it? A lot of people don't like guessing it. Takes too long for their brain. You have to think about it. You could have gone 11 plus 1. There's people who teach swap sides, swap signs. I'll teach that later as a nice little thing to think about, but not when I first started. So this one, I could get rid of that times 5 by going divide 5. More complicated. If I go divide 5, I end up with this one. Fractions. And I've talked enough already about people struggling with fractions, so don't introduce fractions unless you have to, or later on when you're more confident. So how do I get rid of the minus 3? It's all there by itself. It's very easy to remove it. If I plus 3 to one side, I plus 3 to the other side. The 3's are gone. I literally say gone at times. They're gone. I could say 0. We've simplified this to say 5x equals 10. Nice easy one you can see in your head. Actually, sometimes I do watch students trying to guess and students showing some working out, and usually the students guessing is slower than the students working out. You get people very good though. But for the majority of people, they're not that good at it. So that's a times 5. How do I get rid of a multiply by 5? The opposite of times 5 is divide 5. Do it to one side, do it to the other. 5 into 5 goes once, don't need to write the 1. 5 into 10 goes twice, and we've got the answer. Now, our first taste of guessing what this is. Same equation as that, but instead of a 7, I've got a 6. So we're going to get everyone's favourite topic, fractions. So now it's harder to guess it. I'd struggle, no, I wouldn't struggle to guess it, but people will struggle to guess it. So we could get rid of the times 2. Why don't we get rid of the times 2 first? Because it introduces fractions unnecessarily. So I can get rid of the plus 1, opposite of plus 1 is minus 1. If I do it to the left hand side, I do it to the right hand side. So I've simplified this, it's gone, and I've got 2x, you don't have to cross that out, it's just something I do. 6 take 1 is 5. Now it's a simpler, looks simpler, I want the equation to say, here is the answer, so I don't have to think. The incredible part is I have very, very, very good mental arithmetic, but all we're ever doing in math is trying to get it so you can simplify the process so you can think less, which is interesting. In many ways I say that math is a system of how to make us more lazy, but it's not lazy, it's more efficient. So there's a multiply between 2 and that. Why? Because a long time ago a group of mathematicians, I think from France and Italy and Hungary and England, all got together and made that decision. And it works well, by the way. If I divide that side by 2, I divide that by 2, and here's the answer to the question. 2 into 2 goes once, don't have to write it. And actually the answer is 5 on 2. Of course, a lot of people will go 2 into 5 goes twice, and there's 1 left over. So if we started with halves, I end up with halves. You don't have to do this, but you will have teachers that demand you write that, and if you don't, for your better interest, they want to nag you about writing it as 2 and a half. Other thing I could have written instead would have been a half 0.5, so I could have written 2.5. So there we go. The first of the basic ones with 2-step equations, same process. We learn the process so when it's harder, actually see you don't have to think so much. And it's really quick and easy, especially when the numbers become worse. Thank you. Hi everyone, welcome back. Let's have a look at more equations. In the previous video I talked about simple cases where you could just guess it in your head. You could guess that one. I can look at that and go, that's going to be 5, 2 5s are 10, and work out what it is. But what if you can't see that? Because the moment we get anywhere with equations, and anything to do with real life, which is everywhere, like anything you can think of uses equations, we need a method. Now let's have a look at what's happening here. There's 2 ways to do this question. For today, I'm going to show you one. Maybe later in passing I might mention the other one. I prefer to show people one method, get the one method to sink in. Once it's sunk in, or someone's struggling with it, I can show them another method. I think it's too confusing to show people lots of different methods, 2 or 3 different methods. So here we go. My principle of teaching is show one, give people a chance, repeat it a bit, and see if they're okay. So what's can I do with the bracket? In between that's a multiply. Hopefully you've learnt before when we expand brackets, we go 2 times x and we go 2 times 3. So that's called a distributive law. Don't really need to know that it's a distributive law, but we're distributing the 2 onto everything. It's almost like I had some coins in my pocket and I said, oh, I've got 2 of everything in my pocket. So if I had some 5-cent coins and I had some, say, 3 $1 coins, I could then say I've got twice everything in my pocket. And would it make sense to you? Yeah, got 2 of them and 2 of them. So what have we got? Let's use, I'm going to call it the eyebrow method. Everyone calls it eyebrow method. 2 times x is just 2x. Sort of a reminder of what we have done, especially when it gets more complicated. This one will be 2 times 3 is 6. Now what have we done? We've done a positive 2 times another positive 3, so it's all a positive or an addition. We go to 10. Now it's back to the same as the last video. Could go divide 2, divide 2, divide 2. Like I said, one method first. Don't want to introduce fractions, though this one wouldn't introduce fractions. How do I get rid of the plus 6? Opposite, back to obs, opposites to both sides. It's all we're doing all the time, the obs. Like observations, but no, it's different, but it's obs. Opposites to both sides. How do I get plus 6 and minus 6? If I minus 6 on this side, I've got to balance up the scales. So if I took 6 kilograms off this side, it's lighter. Up it goes in the air, either a scale or a seesaw. And I've got to put 6 kilos back onto the other side. Like picking up one of my dogs, they're about 6 kilos. So if I had my dog in my arms and I was balanced up on the seesaw and she jumped off my arms, I'd be 6 kilos lighter, I'd go in the air. To make up for her jumping off, we'd have to remove 6 kilos on the other side, which would be handy if there was a dog on the other side also at 6 kilos. Let's have a look at it. So if I take 6 from this side, I take 6 from that side. Again, I prefer to write it there. Some people prefer it on the next line. It's up to you, but for the moment, all my videos are going to go take 6 to balance it up. What have we done to this? That's gone because 6 takes 6 is 0. So I'm left with 2x. And it's nice. All we've done is we've made this simpler. It's nice to make it simpler so it tells us the answer so we don't have to think. Some people say, oh, just think about it. No, you can get back to this method. 10 takes 6 is 4. Now it doesn't matter how complicated the equations get, same method applies. Now this is a multiplied by 2 again because it was made up by a lot of people a long time ago. So the opposite of that is divide by 2, divide by 2. 2 into x goes once, I don't have to write the 1 for the x, and 2 into 4 goes twice. Let's do another one, it's got a minus. Just give a chance for your brain to take it in. I almost need to just slow down a bit. Between the 3 and the bracket, between any 2 things written together, the 3 and the bracket, there's a multiply. How do I expand the brackets? I use what's called the distributive law. 3 times x is 3x. Remember, x just means a number that we're looking for. Actually, to go back a long time in history, people actually wrote the words, the number or something of that form. Interesting when you look back at it. So this one will be a 3 times 2, which is a 6. This didn't say minus, so 1 minus makes a minus. 2 negatives would make a positive. So you can imagine if I had a minus out here as well, we'll have a positive. But this one is just a minus, equals 6. And here's where a lot of people go wrong and they put 3x equals 0. See it over and over again. What's the opposite of minus 6? Add 6. Add 6 to this side, add 6 to that side. So those who don't think this way and refuse to think this way will often make more mistakes. It's just one of those things when I'm marking, you see all the time, and I'll often have 0 written there. So here we go, a little bit of care to start with. Remember the goal is care now so you can go faster and better later on. So this one is a 3x, so I've made it look more simple. And actually at that point you can look at the question and go 3 4 to 12, but what if you can't tell? How do I get rid of a multiply? I divide. If I divide side, opposites to both sides, opposite of times by 3 is divide 3 and divide 3. 3 into 3 goes once, so that's a 1x, don't have to write the 1. 3 into 12 goes 4. So there's 2 of those, but now let's make it different. We're going to introduce, I keep talking about everyone's favourite topic because it's just so often, this question has a fraction. We don't want fractions where possible. Why do I say we don't want fractions? because too many people mess up with them, which is one of the reasons why the first set of videos I made were on simple fractions. If you want to go have a look at them. So let's have a look. Some people will go multiply 2 and get rid of that fraction first. I'm going to show that method. How do I get rid of a divide by 2? The opposite of divide by 2 is multiply by 2. I multiply that one by 2. This is for later on, it's especially needed, so that's why I teach this one first. If I multiply that one by 2, I'm going to multiply that one by 2, I'm going to multiply that one by 2. A lot of times in tests and exams I see people just writing that. It's like you've just ignored, like the 3 didn't exist. So let's watch out. Can't ignore the 3. So that I can talk about things and why, but for the moment, just don't ignore that 3. So on this one it'll be don't ignore the -1. If I double that, I've got to double that. And I could talk about the seesaw and say we doubled this and we doubled that, but we didn't double one section of the seesaw. And all of a sudden it's unbalanced. It's really about balance. So what have I got? 2 into 2 goes 1, so I've just got a 1x, I don't have to write the 1. 3 2s are 6, 6 2s are 12, and you could just look at that and write the answer down. It is acceptable just to put x equals 6. The method though, how do I, opposites of both sides, I go take 6 and take 6. Balance it up, if I do it to one side, I do it to the other, and there's my answer, x equals 6. So the method is there. Just some people, or so many people, say, no, I can just do it in my head, or I can do this method, or I can go, a lot of people will just go across the page and make a mess, and when it gets harder, it's almost like you go back to them and say, come on, let's start again. So what have I got? I got fractions. I have to think about fractions, and it's always get rid of fractions first, wherever possible. So this says divide 5, so what's the opposite? What divide 5 is? To multiply 5. They're opposites of each other. So if I multiply this by 5, multiply that by 5, I can't just ignore that -1, it's important, and I ignore that by 5. So what have I got? 5 into 5 goes once, so that's a 1x, I can just write my x. 1 times the 5 is 5, and I just wrote the minus there. Could have said that, not got 2 minuses. 2 minuses become a plus, it's only got the 1, so it stays a minus, and then 2 5s are 10. And I do see people struggle when you do this and they'll go, oh, it's 5. No. How do I get rid of my -5? I add 5 this side, I add 5 that side. And of course a lot of people just see this answer as 15. But a lot of people don't. Or don't want to even. What have I got left? Now, -5 plus 5 mucks people up. If I said 5 minus 5, people don't get mucked up. So you can add and subtract in any order. So I could go to teaching what this is, but I'm not. Just going to stick to 5 take 5 is 0. Could just say it's gone. And I've just got x equals 15 and the question tells me the answer. Now beware the trap. At this point I've shown you some simple ones. They can go much harder. They can get annoying numbers. They can be made to look different. One of the things people don't like at the start of our equations is there's so many possibilities. But I'll keep that for another video. Thanks. Hi everyone, welcome back. Look at some more equations, let's see what's going on. First one that looks up here is quite different than what we were doing before because it's got this +3 up here, not written over the side by itself. And I see student after student who go, I'm okay with equations, and they go the opposite of +3 is -3, and I do it to both sides, and unfortunately they get the question wrong. I could go slowly through and show you why it's wrong, but at the moment let's just talk about the technique. This is also showing you why it's wrong. There's actually, that line there, that fraction bar, actually means a bracket. It means that whatever's above it, it's got a bracket around it, and whatever's below it, it's got a bracket around it. When you talk about BIM dash, or whatever you want to call it, BOM dash, depending where you're from, order of operations, the brackets, you can't just pull something out from inside the bracket. So let's have a look at what we can do. What controls that 3 is the plus and the bracket. I could actually write the brackets in there. That's what it actually means. Now this 4 here is controlled by that divide. So that little divide there controls the 4. So I can move the 4 easier than I can move the 3. So a lot of people just get thinking, oh, I can move a 3 when you can't. So let's go back to this 4 here. How do I get rid of a divide by 4? Talk about the opposites to both sides, opposites to both sides, and the opposite of a divide by 4 is a times by 4. So the opposite of divide by 4 is a times by 4. What's the purpose of it? When I times that by 4 on this side, and I balance up the scales, always going to talk about the balancing up the scales. If I multiply this side by 4, I multiply this side by 4. And the purpose of it was, I can then go 4 into 4 goes once. So really I've got 1 bracket x plus 3. So instead of having this 4 controlling all of that, now I've just got a 1 controlling it. Interesting part is 1 of that is just x, and 1 of 3 is just 3. So if I want to, I don't even have to write that bracket there. Once I get rid of the divide by 4. Let's have a look at it again. What's the opposite of a divide by 4? Times by 4. Can't just go subtract 3, subtract 3. Now that I've got this 8 over here, so it's changed the whole question. First of all, we have to times everything by 4. I do have a rule which is get rid of fractions first. I'm always saying get rid of fractions first. I've got all sorts of shortcuts for the higher level year 12. Even now I'm just nagging about get rid of the fractions first. So now I've got what plus 3 is 5. You could have done it in your head and just said it's a 5. This 5 plus 3 is 8. Or I can go take 3 from this side, take 3 from this side. Opposites to both sides. The opposite of a plus 3. What controls that 3? The plus does. So how do I get rid of a plus 3 and minus 3? And now the equation tells me the answer. I want it to say the answer is. And that's all we're doing with equations. Get it to tell us the answer. 8 take 3 is 5. Now if we check it and see what's going on, what if you made a mistake? What if I was actually wrong? If I go back up to here and I replace the x by the 5, I'll have 5 plus 3. When we divide it by 4, 5 plus 3, the original equation, when we divide it by 4 has to equal 2. Now I end up with 8 on 4 equals 2, which is true. So you can actually check your equations. I can remember at school, I would just, at the end, if I had time left over, I'd check the answers. I often found I made a lot of stupid mistakes. So, same question again, got a subtraction, change the numbers, make it look a bit different. If teachers want to make it harder for you, they can put a negative in here, they can put an extra number there, but we'll look at that another day. So we can't get rid of the minus 3 by going plus 3 because it's controlled inside of that bracket. Do I really need to write those brackets there? Not once you understand that it is there. Mind you, a lot of people will do it without understanding it. Cannot go plus 3 because it's controlled. This 2 is not controlled. It's easier to remove. So what's the opposite of divide by 2? Times by 2. So I times the left hand side by 2, I times the right hand side by 2. Let's have a look at what we've got. 2 into 2 goes once. I just do this. I cross them out. I know they're not 0. Be careful they're not 0 because if that becomes a 0, you've got a problem with dividing by 0. So it actually is 2 into 2 goes once and 2 into 2 goes once, and then you've got 1 over 1 is 1. You can just cross them out. So once they're crossed out, I've just got the x minus 3. So it saves me thinking about the brackets. And 5, 2 is a 10. Now I've got that minus 3 in a situation where I can move it easily. Opposite of minus 3. There's nothing else controlling it. Just got a plus 3 to balance up the equation, and I got x equals 13. Again, I could check in the original equation, 13, take 3, when I divide it by 2, it's 10 over 2, which is 5, which is what I wanted it to be. So you could have guessed, you could have stood here and just guessed it was a 13. Now a bit different again. Sort of like that. There are so many shortcuts. Oh, not really. There is a nice quick way, not a shortcut, there's a quick way of doing this when you're more confident. It says divide by 3, I go times by 3 this side, I go times by 3 that side because they're the opposites. I just cross out the 3's. I could go 3 into 3 goes once. If I went 3 into 3 goes once, I got 1 times 2 is 2x. So if you look at what I did, I've just removed the 3's and left me with the 2x. And 8 and 4 3's are 12. And now I've got 2 what's a 12. You could just write down 6. I don't think any teachers will take off marks if you just went now, x is 6, if you see the answer in your head. So we want you to be able to go efficiently and quickly on these. So what's between the 2 and the x? There's a times. If I divide this side by 2, I divide that side by 2. 2 into 2 goes once, I don't have to write it. And 2 into 12 goes 6 times. Again, I could check it on the original. Let's put it back here. 2 by 6 is 12. And when I divide it by 3, I get the 4. So you can always do that, except when they're horrible numbers and you've got no chance. One more, just for good measure. The opposite divided by 2 is times 2. If I times this side by 2, I times that side by 2. 2 into 2 goes once. 1 times 5 is 5. So all it did was remove the 2's. And we're left with 5x equals 20. Maybe your brain will go 5 4s are 20 and write the answer down. If it doesn't see that, or it's got fractions and negative that make it more difficult, there's a times between any two things. There's always a times, as long as there's not two numbers. So how do I get rid of the times of 5? I divide this side by 5, divide that side by 5, and the quickest way to write divides that way. I do have students who want to write 5x equals 20, and they write divide 5, divide 5. If you're one of those, it's okay, but when things get harder, it just becomes a mess. Let's have a look what's happening here then. 5 into 5 goes 1, so that's just an x. And 5 into 20 goes 4. And again, I could check it. 5 times by 4 is 20. When I divide 20 by 2, I get 10 from the original question. Thanks for that. See you in the next video. Hi everyone, welcome back. I suppose if I go to the number, this will be my number 4 video on solving equations. This one's about a thing called cross multiplication. I'm going to show you a little bit why it works. If we had 2 quarters, I could say that 2 quarters is the same as a half. Let's have a look what we can do when it's one fraction this side, one fraction that side with it equals in between. If I multiplied that 2 by that 2, put the equals in between, so I started here. Don't have to start there, but I'd like to teach people to start there. Get in a habit, so you're doing the same thing all the time. 2 by 2 and 1 by 4. So we've got 4 equals 4. So when a fraction equals a fraction, we can go that times that equals that times that. The reality is you can go the bottom times the other top equals the bottom times the other top, and you can do that in any order you want to do it in. So if I had another one like, let's say it's 4 on 6, and I know that's 2/3, so if I half the top by half of the bottom, let's have a look at it. Now I'm going to put this cross in here to remind myself I'm allowed to go 4 to the 3, 4 times 3, and I'm allowed to go 2 to the 6. Now, it wouldn't matter if I went 3 times 4 or 4 times 3, it's the same thing. So that's 12 equals 12, and we know it's true. So can we use it on equations like this? Yes. Are there other techniques? Yes. One technique you can do is turn them upside down. But let's have a look at this because this is really handy at times. I'm going to put my little cross multiply in there. I'm going to write the ones with the x's first. I could write that first, maybe I will. Let's go like I said, I have it. 2 times 3 is 6, x times 1 is 1x. And you don't have to write the 1, so the answer is actually 6. So the answer is 6. Let's check it and see. If I wrote that 6 in there, 2 over 6 does equal 1 over 3. So yes, it's correct that it was x equals 6. Maybe you could have guessed it. This one's maybe a little bit harder to guess. I'm going to put my cross in here for cross multiplication. So I'm going to write that one first, starting here. Don't have to, but I'm just going to. 5x equals 1 times 4 is 4. Now I've got between the 5 and the x's a multiply. How do I undo a multiply? I've got to do a divide. I've got to balance up the scales. So if I divide this side by 5, I've got to balance up the scales, divide that side by 5. If you're not sure on that, please go back to the other videos and have another look at it. How many times does 5 go into 5? It's just the once. Don't have to write the one, so that's x equals 4/5. Now, imagine trying to guess that one from the original question. 5 over 4 equals 1 over what? And the answer is 4/5. I could probably ask a lot of classes and no one will have an idea. No one will have an idea. It's quite surprising what people come up with though. Now we look a little bit more complicated. I'm going to put my thing like this in. Do I need to start at the 1? Now I'm going to say to you, It isn't nice if you look for where the x is. The x is what we're trying to find. So if I did 2 times 2 is 4 and an x, and I wrote the other one, 1 times 3 is 3. What's between the 4 and the x? Now it's repeating. And now if I divide this side by 4, I divide that side by 4. And then you got the usual question, how many times 4 go into 4? Once, don't have to write the 1, so the answer is 3/4. And again, imagine trying to guess that from the equation. Last one, what looks different about this? Looks like 2 isn't a fraction. Just remember, 2 is always a fraction. 2 is just a fraction of 2 over 1. So 3 would be 3 over 1, 4 would be 4 over 1. Cross multiply, I just look at those there. Oh, by the way, if you look at all these, probably the best time to cross multiply is when x is on the bottom, when x is on the bottom, when x is on the bottom, and lastly here when x is on the bottom. When it's on the top, you don't have to. There's quicker methods, I'll show you that in another video. We'll come back with a revision set. I'm looking for the x. I could have written that first. I'm going to write that one first. 2 times x is 2x. 1 times 4 is 4. Same as always. What controls the 2 between the 2 and the x as a multiply? How do I get rid of a multiply by 2? If I divide this side by 2, divide that side by 2. How many times does 2 go into 2? And if you notice, I'm saying the same thing over and over and over again. But that's what it is, and giving your brain a chance to take it in and be comfortable with it. I could check it. That one wasn't too bad. 4 over 2. How many times does 2 go into 4? Twice. So I could have done that one in my head, but really, when I watch a lot of students, a lot of people don't see it. Thank you. Hi everyone, welcome back. If I gave you some number, this would be video number 5 in the equations that I've just been doing. I look at these ones, I feel like saying these are weird cases. They're not weird cases necessarily, but they're just a bit different. So you're sitting in class, you're doing all the questions in the textbook or you're on the worksheet, and you get to the test and it's different. And it throws you off and you think, what's different? What made it different? Why did I get it wrong? Someone shows you afterwards and you go, oh my goodness, I could have just done that question. So let's have a look at some of them that just look a bit different. This one had an x here and an x there. So this is called collecting like terms. Just a normal, everyday, simple question. And maybe you don't fully understand collect like terms, or you don't realise you can just go 3x plus 2x is 5x. If this was an x and this was an x, I can add them together. By the way, let's say we were looking for this answer to the question you were trying to guess, you could just think of it as 3x and 2x and make 5x. And then guess the answer to the question. And then you go 5 what's 10, and you go 2. But let's do it properly. Between them there's a times. How do I get rid of a times by 5? I divide this side by 5, divide that side by 5. 5 and the 5 goes once, you're left with an x. 5 and the 10 goes twice. So let's check out and see. 3 by 2 is 6. 2 by 2 is 4. So 6 plus 4 makes 10. So collecting like terms is about, we're actually adding those numbers while those x's stay the same. But just remember, in reality, we know these are 2's. So I've actually got 3 lots of something plus 2 lots of something. Here's 5 lots of something. Now let's have a look at this one. What do I say in previous videos? Everyone goes wrong. They go -1, -1. And if I had a dollar for each time people said that, I'd be able to buy myself a new car, I think. It's a nice way to put it. Let's have a look. The 1 is under the control of that bar there. And that bar actually says there's a bracket there and a bracket there. But we don't write the brackets because mathematicians know that there's a bar there because of that. So the 1 is stuck inside. I can't just pull it out and take away 1 because of order of operations. Have a look at the 2 though. The only thing controlling that 2 is this divide by here. So there's a divide by. So that's how, what's the opposite of divide by 2? I'm going back again to the opposites to both sides. I'm always going to talk about just do the opposites to both sides. No matter how hard it gets, just do the opposites to both sides. So what's the opposite of divide by 2? Multiply by 2. If I multiply this side by 2, I multiply that side by 2. Now by the way, I do see students who do this. They know to go times by 2, but they write it down there. And then they get in a mess because they write 5x plus 1 over 4 And they go, I thought I knew what I was doing, but I just made it worse, and they don't know why they made it worse. So you might notice my habits all the time. This one's a bottom or a denominator. I make it, when I multiply it by 2, I try to make it look like it's a top or a numerator. Because a top can cancel with a bottom, so that's why we can just cross them out if we want to. Or I can go 2 into 2 goes once, I don't have to write the 1. By the way, if I didn't have that bracket written there, they just disappear. The purpose is get rid of that divide 2 on the bottom. So now I've got 5x plus 1 equals 8. And now it's like the question we've done previously. I'm going to shortcut a little bit. Opposite of plus 1 is minus 1. If I minus 1 there and minus 1 there, I could have gone divide 5 first. Most people mess it up when they do. And also it becomes fractions, which is not nice. So let's have a look what's happened. The 1s are gone. I'm left with 5x equals 7. The last bit is, how do I get rid of a times 5? Back to that again, divide 5. If I do it to this side, I've got to do it to the other side to balance up the scales. And the answer is actually 7 on 5. By the way, you could say, how many times does 5 go into 7? Goes in once. How many are left over? 5, 6, 7. There's 2 left over. So if you started with fifths, you end up with fifths. So 1 and 2 fifths would be a hard one for me. Talking about when I was at school, I put the numbers back in like I did here in the check. This one's harder to do. Much harder. Now what makes this one different? The bracket. And not only is it the bracket, but it's also got the X written over here instead of there. Doesn't really make any difference. I've still got to multiply between any 2 symbols. There's a multiply, unless it's 23 or 37, then it's just 2 numbers. Let's have a look what it is. That eyebrow reminds me that I've gone 2 times 4, which is 8. That eyebrow, you don't really need it for this, but I want you to see it still. Reminds me I've gone 2 times 3x. So everything in here gets doubled. That's all that says. Everything in the bracket will be doubled. So the 4 will become an 8 and the 3 will become a 6, and still got the 8. Now here's another thing I can do in tests and see students muck up. They'll go there and take 6 because they think they're removing the number at the back. They're not. They're removing the number by itself. This is married to the 6 with a multiply, but the 8 is by itself. So I can very simply just go go to red. I can go take 8 from this side, take 8 from this side, and then the 8 take the 8 is gone, 0. And now this is a 6 times x, and then 9 take 8 is 1. What's the opposite of times by 6? Divide by 6, divide by 6. Now some of you will go, I've heard Mr. P saying the same thing over and over again. Have patience. It takes, just watch it for a little bit longer. Not necessarily right now, but just keep hanging in with the method. In the long run, I know what people do. 6 into 6 goes once, so I can just write the x, and the answer is 1/6. Now I'm imagining guessing 1/6 for that. And by the way, if the teachers really want to muck you up, they can put in negatives and make it worse. So let's have a look at this one. The 3 is married to the x. The 4's got the divide, keeping it with the x, but the 1 is sitting there all by itself. There's the 1 by itself. So I can get rid of that first. -1, -1. If I wanted to, I could multiply this by 4 and that by 4 and that by 4. Not a bad method. Sometimes I'll go back and teach people that. Let's have a look what's happened then. I've left with a 3x over 4. That's gone. 3 take 1 is 2. Now I could cross multiply if you watched the previous video, but when the x is on the top, it's not a great advantage to cross multiply. So if you want to see cross multiplication, just go back to the previous video. This says divide by 4. How can I get rid of a divide by 4? I multiply by 4. If I do it to that side, I'm going to balance up the scale again. I multiply that side by 4. This is where the videos get longer and information. 4 into 4 goes once. So I've actually got 1 times 3. So I've actually just got a 3x. I've got an 8. Here we go, nearly finished. Times by 3 is a divide by 3. If I do it to the right hand side, I've got to do it to the left hand side. If I do it to one side, I've got to do it to the other. And here's where people come unstuck with their fractions. 3 into 3 goes once, so I don't have to write the 1 for the x. And how many times, no, actually 8 on 3 is the answer to the question. I usually like to write or. So there's another possibility of what you can write that as. We could write it in all sorts of ways, decimals and you name it. 3 into 8 goes twice, so 3 and 3 is 6, and there's 2 left over. If I started with thirds, I end with thirds. And there we've got 4 fairly unusual cases. The only thing your teachers can do now would be make them a little bit more complicated, or put more negatives in, or even put fractions in to make them look harder. Thanks. Hi everyone, welcome back. I've made 5 videos on 2-step equations. Can't call them all 2 steps because I've added to them. But normally in year 8 and 9 we get to this certain level of questions, maybe depending on what class you're in, you might go further on the equations and get more complicated. Want to make some videos where just revision, you can watch the night before a test, or you could watch just to make sure you're okay with all the concepts if they're put together into one. So here we go. 6 examples squashed on the one whiteboard. Let's see how quickly, but not too fast, that I can explain them. The goal of solving equations, if you watch previous videos, is get the x by itself. So we want the equation to say the answer is. And how do we get an equation to say the answer is? By it saying x equal. We can talk that to make the x a subject. It just says the answer is. So I need to get rid of that 3, and I also need to get rid of that 1. I can choose to get rid of the 3 first, or I could choose to get rid of the 1 first. If I get rid of the 3 first, there's a multiplication between the 3 and the x, and the opposites to both sides. The opposite of timesing by 3 means I'm going to divide by 3. If I divide by 3 here, I need to divide by 3 there, and I need to divide by 3 there, and you start introducing fractions. And one of the biggest topics that people muck up on is fractions. Just reading the exam report a couple of days ago from the Year 12 Methods High Level exam here in Western Australia. It actually talks about one of the questions, the weakness that people had with fractions. It just happens over and over again. So beware fractions as much as you can. So let's get rid of the +1 first because it's easier to move. It's not doing multiplication and division. So how do I get rid of the +1? I -1 from this side to balance up the scales. If I -1 from this side, it's 1 lighter. If it was kilograms, it'd be 1 kilogram lighter. And so that would go up. To balance it up, we're going to -1 from the other side. So if I -1 from the other side, I like to write it up here so that you don't have to write another line of working out. Let's have a look what we've got. So now we've got 3x, 1 take 1 is 0, so I don't have to write +0. And then 4 take 1 is 3. And basically now it tells you the answer that you could have looked at in the first place. But remember, it's the method that matters, not whether. You can look at the simple question and get the answer. So try to be patient with it and take your time on the method. Even if the method seems awkward and uncomfortable to start with, it gets easier after a little while. So now I've got a times by 3 and the opposites to both sides. What's the opposite of times by 3? I divide this side by 3, balance up the scales. I divide this side by 3, and 3 into 3 goes 1x, and 3 into 3 goes 1. So the answer is 1. So really we're just talking about the answer is 1. So that's the first one. Now the process is explained there. Let's go for this one. If I add 1 to this side, I add 1 to that side. I could have divided by 5, but it will introduce fractions, and too many people struggle with fractions or make silly mistakes with them or really don't understand fractions. So what have I got now? This -1 plus 1 mucks some people up. You can do it in reverse. It's 1 take 1. So if I wrote that as 1 take 1, everyone would be okay and say it's 0. So the purpose of writing the opposite is to get rid of something. So the opposites of both sides is so I can get rid of that -1. So if you don't want to think about the negatives too much, we're getting rid of a -1 by going +1. So you're left with 5x equals 4. Now there's a multiplier between there, just like the previous question. The opposites, divide by 5 this side, divide by 5 that side. 5 into 5 goes once. I don't have to write the 1 because the answer is x equals 4/5. Now that's one that'd be harder to guess. Some people can. I've tested many classes on it verbally and people can work it out because they're very sharp at their mental arithmetic. This one's got an extra step. This is what happens in tests. This looks different. This looks different. This looks different, and so does that one. So let's have a look at it. There's a multiply between the 4 and the bracket, just like we had a multiply between the 5 and the x. So the rule is anything, two things written next to each other, have a multiply in between. except if we write a number like 17, it's not a multiplication between the 1 and the 7. So I use the eyebrows. This means 4 times everything in the bracket. So we've got a 4 times x is a 4x, and then the rest of it is the 4 times 3. The eyebrows, especially as it gets more complicated, makes a big difference in organising people. So the 4 3s would be 12. Now we're back to, by expanding the bracket, the question looks like those. And again, I made it so it wasn't nice numbers. So if I get rid of a 12, if I subtract 12 from this side, I subtract 12 from that side. Now I'm left with 12, take 12 is gone. So I'm left with 4x, and taking away more than what you had, and we've got a minus 1. So you could go up and down the thermometer and work out 11, take 12. But you can watch that on other videos on negative numbers. Between the 4 and the x's are times. If I divide this side by 4, I divide that side by 4, and I've got an answer of 4 into 4 goes 1, so that's a 1x, and the answer is minus a quarter. That would be hard to guess. Go to this one. Looks the same, but it's got this part here, which is a divide by 2. I could just go multiply by 2, multiply by 2, multiply by 2, and some people prefer that, and that would be one possibility. This one's a plus 3, I could go minus 3, minus 3. For the moment, I'm going to go multiply to show you what happens, because this is handy when it gets to harder questions. So if I multiply this one by 2, I multiply that one by 2, and I multiply that one by 2. Don't forget, there are 3 things here. We talk about terms, there's 3 terms here, and there's an equals in between there. So I've made the 2 look like it's a numerator or a top, so your brain can cancel out the 2 with the 2. And here's the question, how many times does 2 go into 2 when it's once? I don't have to write the 1x. Now I can go 3 2s are 6, and I can go 5 2s are 10. Then the last step, I can go subtract 6, subtract 6. If I want to get rid of the plus 6, I subtract 6, and then I'm left with x equals 4. Could have done the question again. I could have just gone x on 2 plus 3 equals 5. And if I would have gone subtract 3 first of all, do it to both sides, and I'm left with x on 2 equals 2. How do I get rid of a divide by 2? If I times this side by 2, I make it look like a numerator. So this is a numerator and the denominator at top and the bottom. I multiply this side by 2. I get the same answer as before. 2 into 2 is 1, which is just an x. I don't have to write the 1x. So it's not that the x is 1, it's a 1x, 1 of x. 2 2s are 4, and you've got the same answer as before. So it's your choice which way, all the way through these. On this one, what a lot of students do wrong, they go plus 3 to both sides there, and the moment they do that, they're going to get the incorrect answer. And the reason they're getting the incorrect answer is that fraction bar means that there's a bracket around this. We don't have to write the bracket, but it is there the whole time. So every time you're doing a fraction, there is a, I like to do this, bracket around the top and a bracket around the bottom. So obviously no need to put a bracket around 5. So you can't go plus 3 because the bracket there, the vinculum, the fraction bar, is controlling that minus 3, so you can't just pluck it out. So here we go, if I want to get rid of divide by 5, the opposite of divide by 5, the opposites to both sides. If I multiply this side by 5, I multiply that side by 5. Let's have a look what happened. 5 into 5 goes once, so we've got 1 of the x, and we've got 1 of the 3, and it's got a minus. So 5 into 5, all I do is cross them out. I think of them as gone. Just be careful if you think of them as gone, that they're actually 1. So it's not 0, because that would make our whole question up. So I cross them off, and we're left with just the x minus 3, so I didn't complicate it by putting the brackets in. Just cross them off, and you've got a 5. Now you've got a really easy question. How do I get rid of a minus 3? I add 3 to both sides, because it's the opposites to both sides. People still have trouble with this. It's really 3 take 3 is 0, so I'm just left with an x, and that's an 8. So the question tells us the answer. I could go back and check, put the 8 in instead of the x. You have 8 take the 3 is 5, and when we divide the 5 by the 5, I end up with 1. So you can check your answers are right. 6 is just a little bit of a trick, not much, but it's amazing how many people it throws off. A couple of things I've done, I've left this as a 1x. So we've got 2 lots of x's here. When we want the question to say x equals, we just want x. We don't want x and more x's around the place. We want it just to say x. So 4x take 1x is 3x. And if you haven't learnt collecting like terms, as long as the x's are the same, with the same powers, I've had 4 of them and I subtracted 1 of them, I end up with 3 of them. So the x's don't disappear. It's really the numbers at the front. 4 take 1 is 3. Then I've got plus of 3. So all I did was add in an extra step to make it more confusing. Now it's like doing one of these. So fairly quickly on this. Opposite of plus 3, opposites to both sides, and no rush. If I subtract 3 from this side, I subtract 3 from that side. And a lot of teachers like you to write that on a separate line. That's okay, just do it till you get the hang of it. It works. 3 take 3 is gone, so I've got left with 3x. So we had something complicated that becomes just a 3x, and then this becomes just a 3x by itself without that 3 there. 8 take 3 is 5. Now a little bit on fractions I did on purpose. Between the 3 and the x's are times. The opposite of times by 3 is divided by 3. If I do it to one side, I do it to the other. Balance the scales up, opposites on both sides. And I'm left with this answer of 5 1/3. And again, because of this topic of fractions, I know that so many people have trouble with fractions. Let's have a look what happens. How many times does 3 go into 5? I could do this. 1, 2, 3, 4, 5. If you're okay with this and you know it's 1 2/3, don't need to watch the end. 3 into that goes once. 3 into that goes once. And it's got a remainder of 2. So primary school, some people will teach with an R of 2. So there's our remainder of 2. And if we're talking about thirds to start with, we're talking about thirds to finish with. Depending on your teacher, a lot of teachers will accept 5 and 3, or you can change it to 1 2/3. Usually in year 7, 8 and 9, teachers will insist on you changing it into 1 2/3. Some people like to write as a decimal. Decimals can be inaccurate. There's 1 2/3, 2/3 is 0.6 repeater, and you watch so many people with decimals write that as 1.6. Then you're asking for the teacher to take marks off that you knew how to do the equation, but you didn't know how to get the decimals correct at the end. So be careful if you're writing it as decimals. Fractions are very easily what we call exact. There's no approximating, whereas the decimals, people can make mistakes when they're rounding off and doing all sorts of things with them. Thank you. Hi, welcome back everyone. This is my second playlist on equations, on solving equations. In the first one, I only dealt with situations where there was only x, and there was one x in particular, and it was only on one side, of course, of the equal sign. In each of these ones, I'm going to have an x on each side of the equal sign, and in follow-up videos, we'll end up getting into negatives and fractions, and also a little bit of brackets here, and looking at what complications we can have to throw people off in exams. Very common. There's 2 things I always talk about, or actually there's 3, that are the major things that affect people in year 12 still. One is fractions, another one is negative numbers, and then the big one is equations. It's amazing how many people know the rules, but just make mistakes and don't know where to go wrong. So if you can keep looking at these videos and progress through them, it's the ones that come will give you more details of where the problems normally exist. But this is your first one in terms of x each side. My problem is, I look at this and I see there's an x each side, and it says, well, that's going to need to be sorted out. I want the equation to say to me the answer is, and that's what we mean by saying x equals. We're saying the answer to this question is. I could look at it and try to guess the numbers again, and it wouldn't be too bad on that question. You could start with try 1, try 2, try 3, until you find out the number that makes it true. But more important than that is the technique. I do tend to say to people, if there's x's on both sides, get rid of one of the x's on one of the sides. Now, most of the time we're going to end up with an x on the left. Most teachers will teach you that way. Doesn't really matter if you're ending up on the right. Maybe in some countries or some places it does matter. So I want to get rid of this 3x. Now I can't just go take x, because the 3 is actually what I call married to the x. Talk about marriage and divorce in terms of multiplication and division. Sometimes I use these things to try to get it to sink into your brain a bit better and gives you a bit of a handle. You can talk about marriage and divorce. Sometimes I don't talk about it at all, but I just mentioned marriage and divorce. I can't just separate that x from the 3 by subtracting it. But I can subtract all of 3x from this side. And if I subtract all of 3x from the right-hand side, I've got to subtract all the 3x from the left-hand side to balance it up. So if I take 3x from that side and I take 3x from that side, I'm left with a 5x take the 3x is left with 2x. Then I've got plus 2. The 3x take the 3x is gone, which was the whole point of what we did here, was to get rid of the x from the right-hand side, so that on the right-hand side we now only have 6. The interesting part now is back to the original two-step equations I had on the previous video. So now I can get rid of that 2 by going divide 2, divide 2, divide 2. As I always say to people, if you do division first, sometimes you're introducing fractions, especially as they get harder. So I prefer to get rid of the 2 first and the opposite of a plus 2. Remember, I'm always going to be talking about the opposites to both sides. Opposites to both sides, and the opposite of plus 2 is minus 2. And I want to do it to both sides. If I'm minus 2 from this side, I'm minus 2 from that side. So what have I got? That's gone. 2 take 2 is 0, so I'm left with just a 2x. 6 take 2 is just 4. And at this stage you could have just gone 2 2s to 4 and you could write down the answer of being 2. For those, when it gets harder, you might notice it. That's a times by 2. So how do I get rid of a times by 2? I divide this side by 2. I divide that side by 2. 2 into 2 goes 1. I don't have to write the 1x. I can just write x equals 2. So the answer is 2. If I go back to the question, 5 by 2 is 10. Plus 2 must equal 3 by 2 is 6 plus 6, so we've got 12 equals 12. So 2 is the only number in the world that will make that equation true. So for each of these, there will be one number that makes them true. There won't be 2 or 3, or occasionally 2 or 3. There's only one. There will always be one that we can find. So on this one over here, we want to get rid of the x on the right hand side, because there are x's on both sides. Come back to all the times, like the first moment you look at an equation, x's both sides. I want to get rid of this 3x. If I take it from the right hand side, I've got to take it from the left hand side. 4x take 3x. I'm only left with just an x. And I mean, you could just look at it and guess the answer. What plus 3 is 4. If you weren't sure, you can go take 3. Opposites to both sides, the opposite of plus 3. And you got 1. So deliberately made that one. Sometimes it throws people off when it's just so simple. Sometimes the simplest ones make people up more than all the others. So this one here, I've got x's both sides, but what makes this one different is that this one is bigger than the 2x on the what we call LHS on the left hand side. So this is bigger. Some people prefer to go take 2x, and instead of having the x on the left hand side, you have it on the right hand side. Right here now I could go both, but it tends to get too long-winded. So let's get rid of that bit there. So I'm still going to go take 4x just to see what happens. Might change my mind in a moment and do it different. If I take 4x on that side, I take 4x on that side. Remember, the reason for doing that is so that x will be gone from one side. In this case, I do talk about creatures of habit. A habit for me, for most people, I'll originally try to get people to focus on getting it away from the right hand side. So now this is gone, we're left with just a 1. So I go to minus 2x. Now here's, be careful, the 2x minus 4x. We've taken away more than what we had, so we end up with a minus. So there's plus 9. So now, would it have mattered if I have the minus? Well, yes and no. How do I get rid of a plus 9? If I take 9 from this side, I take 9 from that side. And I've got minus 2x. It's 9 take 9 is gone. 1 take 9 is minus 8. You can get to there and just go, well, they now both become plus. Could talk about that some length. 2 minus to make a positive. You can, if you want to talk properly, if we go back to that was a minus and that was a minus, if I multiply this side by minus 1, and multiply that side by minus 1. Now your rules of 2 negatives apply. 2 negatives, always doing 2 negatives make a positive. So 2 negatives, like they join up with each other, they become a positive. So those 2 negatives become a positive. If you want more negative numbers, I've got some playlists on negative numbers. So that just becomes a 2x. And then these 2 negatives, when you're multiplying, they become a positive, so that becomes an 8. So in reality, once you've got the hang of it and you're used to it, you can just go plus and plus. So you don't need to really write that down. Or in reality, you can also just do it in your head. You can go 2 watts or 8, you can just say 4. Nice and easy at this stage because every answer here has got a whole number. 2 into 2 goes once, and I have to write the 1. 2 into 8 goes 4. What can we do here? We're going to remove the brackets first. I cannot go take 3 here, take 3 there. Oh, I could try to do it, but mathematically it won't work. The reason it won't work is that bracket controls everything that's inside. Think of BIMDAS. By the way, Western Australia teaches BIMDAS. I know when I was younger as a teacher in New South Wales, they'd say BOMDAS. But the brackets have the power. So these brackets have the power over what's inside. So you can't just go take that 3 to get rid of it. So first of all, we've got to expand the brackets with the multiply. So the 4 times the x is 4x, and the 4 times the 3 is 12. 2 times the x is 2x, and 2 times the 10 is 20. So really this is the same as what we started with on this equation over here. It's just got that extra step involved. Then teachers sometimes try to put extra tricks in, but we might look at those later. So I don't want x's on both sides. Normally I get rid of it from the right hand side, so I go take 2x from this side, I take 2x from that side, the opposite to both sides. And I've got 2x plus 12, 2x's are gone, and I've got 20 left. So watch out for this one. It's really collecting like terms. 4 is something, take 2 is something equals 2. You used to sometimes talk about 4x raised, take away 2x raised equals 2x raised. Mathematically it's not really true, but it does help a lot of people. So now I want to get the x by itself. I can get rid of the 2 first, or I can get rid of the 12 first. Always easier in the long run to get rid of the plus 12 first. I subtract one side, I subtract the other. So this is gone, which is the whole point. Make the equation, each step look simpler. That's 8. What controls the 2? There's a times. If I want to get rid of a times 2, I go divide to this side, divide to that side. Remember, it's the opposites of both sides. 2 divided by 2 is 1. I can just write x, don't need to write 1x. And how many 2's go in the 8? 4 times. So I could put that back into the equation and check it. Maybe I will. 4 into there would become 4 times 7. And over here it would become 2 times 4 plus 10 is 14. And 28 equals 28, so it's true. Thanks. Welcome back. Second of the videos in having an x on both sides of the equations. If this is the first time you've seen me teaching equations, there's a previous playlist that builds up to this, which is the simpler and more basic forms of them. Let's have a look at what's going on here. What I'm going to nag about is the same things all the time. I call them the obs, which is the opposites to both sides. On any equation, anywhere, we want to balance them up. If I add 2 kilograms to this side of the scales, it would make the scales go down. To balance it up, it's getting 2 kilograms on the other side. If I add 2 kids on this side of a seesaw, or add 1 child on this side of the seesaw, if I add a child who's about the same weight on the other side of the seesaw, it balances up. If I take one off one side, it unbalances it, and so to balance it up, you have to take one off the other side. If I halve each side, same principle. So opposites, when you do it from one side, you do it to the other side. What makes this stand out more than any other concept that's involved in this question is there's an x on the left hand side of the equals, on this side of the equals, and there's an x on the right hand side of the equals. We don't want the equation to say x equals something x, we just want the equation to say x equals. So what we're looking at is getting the equation to tell us the answer. So we don't, I really talk about we don't have to think. You can talk on my Year 12s yesterday, I was talking about the fact that a lot of what we do is so you learn the process, you don't have to think. Over the years, students have fought, many students have fought, probably not thousands, but I have taught thousands of students. There would be quite a significant number who would just not want to do what I said and wanted to do different methods. I will compromise and teach you a lot of things once you get the hang of it, if you were in my class. And if you say, and then I'll say if you prefer this method, it's better than that method for this reason, and talk about it. But for those of you who want to just accept what I'm going to say at the moment, get rid of the x from the right hand side. How can I get rid of a 2x though? They're joined together. I can't just remove the x. If I take 2x from that side, I get that whole term removed. Remember, we talk about these are terms. Terms are separated by pluses and minuses or equals. So there's 2 terms here, there's 2 terms there. Technically, in a way, you could say there's 4 terms altogether. So if I take 2x from the right-hand side of the scales, take 2x off the left-hand side of the scales, remember it's not 5 take 2 equals 3, it's 5 x's take 2 x's. By the way, if x happened to be 10, that'd be 50 take 20 would be 30. So maybe your brain struggles with the idea of what's actually going on with the x's. If that was a 10, that'd be 50 take 20 would be 30. If it was 11, it'd be 55 take 22 would be 33. So we're trying to figure out what the x is, and in real life, it's everywhere, and everything we do, every calculation for everything is working out an answer, or we talk about a solution to our problem. So I've got a 5x take a 2x is a 3x, plus a 3. 2x take 2x is gone. I could say 0, I'd like to say gone, equals 5, and now we're back to simple equations. If we got rid of that 3 first, the problem would be it quickly introduces fractions in the questions. Wouldn't be too bad on this question, but let's just have a look for the moment. If I get rid of the plus 3 first, I get from the left hand side, I also do it to the right hand side. So we're trying to get the x by itself. So I could get rid of that 3 first by going divide. If I divided there, I'd have to divide there, I'd have to divide there. So now I'm left with just the 3x, because 3 take 3 is gone, and 5 take 3 is 2, and everyone's favourite topic, between the 3 and the x is a time. So how do I get rid of times by 3? I divide by 3 and I divide by 3, and the answer is 2/3, which is talking about everyone's favourite topic. Quite okay, but it's just 2/3. People want to write 0.6 repeater and also cut off the decimals. Trouble is if you cut off the decimals and you write 0.6, you're actually incorrect. You're actually quite very rough incorrect. Some people would write 0.7, still incorrect. It's rough, but too incorrect. If you had 0.67 and you stipulated that you use 2 decimal places, probably be okay, because it's actually correct to 2 decimal places. But it depends on the question and what it's asking for. Better most of the time just to leave it as fractions, because fractions are what we call an exact answer. So if you want the accuracy later on, the exact answer is more accurate for your calculations. Okay, this one over here, quickly through the process. I want the x to only be on one side, so I'm going to remove it from this side. If I remove it from the right hand side, I remove it from the left hand side. Now, so I have seen people over the years go, x take x is gone, so they're left with 4. It's not that. It's actually 4x take 1x is 3x plus the 1. The x take the x is gone. Be careful here, you've still got the minus. So that minus just doesn't disappear. It's actually a -6 in that sense. So now if I get rid of the minus 1, the plus 1, I go minus 1 to the right, I go minus 1 to the left, I go minus 1 to the right. I'm left with a 3x because the 1's disappear. Now the trap here is the -6 minus 1. I know a lot of students struggle with it. So if we start at -6, all that means is we go down 1. So if I went down 1 from -6, it becomes -7. So there's where we go. Down 1. -6 minus 1 is not 2 negatives becoming a positive. It's just moving up and down a thermometer or a scale. So now I've got a -7. Here's where people tend to go wrong. If I divide this side by 3, I divide that side by 3. Not only do we have a negative answer, we've got fractions as well. Technically, that's the answer to the whole question. But you will have teachers, and I have expected over time, that students change that into whole numbers as well as fractions, which we call mixed fractions. 3 goes into 7 twice, and there's 1 remaining. So 3 and 3 is 6. There's 1 remaining. If we started with thirds, we end up with thirds. And don't forget, if we started with negatives, we end up with negatives. This one here, what makes it different is I didn't write the x at the front. It's like, you see question after question written the same, and we suddenly make it look different. I get rid of that 2x there, I go take 2x on the other side, opposites to both sides. Don't want the x on this side, so get rid of it. I could have gotten rid of the 4x on this side, but on this one it's obviously easier to end up with just the 2x here. So I've still got the 3, but I've got the 2x. 2x, take the 2x is gone, I've left with a 1. Now the traps that happen. Students are used to going take 2, but that 2 is connected to the times, to the x by a times, by a multiplication. So I could go divide 2, divide 2, divide 2. But if you look at it automatically, you've got fractions, and fractions tend to cause people more problems. So the 3 at the front is still just a 3. How can I remove 3? I take 3 from the left-hand side, I take 3 from the right-hand side. 3 take 3 is gone, so I'm just left with 2x. 1 take 3, you're taking away more than what you had. Could go back to a thermometer or scales and talk about what it is, but that's a -2. What's between the 2 and the x? The times. How do we get rid of a times by 2? Divide by 2, divide by 2. And the answer is 2 into 2 goes once. How many negatives do we have? Now remember, 2 negatives will make a positive. Well, we've only got 1 negative, so the answer is x equals -1. Last one, basically the same as that, but we've got the brackets as well. So the 3 ones are 3, the 3 times x is a 3x. And you go, well, how many negatives have I got? This is a positive, times the negative is a negative. 2 times the 2 is 4 with the x, so we're doing a multiplication here. So it means multiply everything in the bracket by 2. This one was multiply everything in the bracket by 3. So 2 3s are 6. There's no negatives involved, so it's an addition. It was an addition. It stays an addition. Now, we want to get the 4x removed from the right-hand side. I do know, it's really nice often, if I want to get rid of that -3x here, it all becomes positive on that side. There are so many other shortcuts as well, but we won't get there today. Here we go. I'm going to stick to going take 4x. For those of you who are like a habit and the same procedure each time, I'm going to stick at that for the moment. So now we're left with 3. If you're -3 and you're -4, we are going down 4 from -3. So I could start here at -3 and go down 4. And I end up at -4, -5, -6, and -7. So that's -7x. The 4x, take the 4x is gone, and then we've got a 6. Now I could go, this is where it really becomes revolting, divide -7, divide -7, divide -7. That's why I've been nagging over many videos now to say, don't do the division first. The -7 is multiplied with the x, it's connected to the x. So instead of that, it's easier to get rid of the -3 first. So I'll get rid of 3 first, I should say, by going -3 this side, -3 that side. Now, don't forget, a lot of students will just write 7x equals 3, and they won't realise they're wrong. You get a test back and you go, oh my goodness, I got it wrong. And you don't know why you got it wrong till afterwards. It's still got that minus there. So you could say it's a -7x. So there's the negative still there. So we use negative and minus interchangeably. Now I can get rid of that by going divide by -7. If I do it to the left-hand side, I do it to the right-hand side. By the way, how many times does the -7 go into a -7? It fits in once. So you can see why the two negatives have to become a positive. Because they fit into each other how many times? Once. I don't have to write the 1x, I can just put the x. And the answer is just 3 on 7. But instead of being a positive 3 on 7, it is a negative 3 on 7. Now can you imagine putting that back into here and trying to see if you're correct? It's messy. So in the long run, this is the first time we're starting to get serious about getting, I'd call them revolting answers, but it's just a bit harder answers than the simple ones like 1, 2 or 3. In the next video, we'll go a step further and make it a little bit more complicated and show you, once people get the hang of it, what we do as teachers to then make it more challenging. Welcome back. This is the third in the second series of playlists on solving equations. So what's happening in these ones I talk about, there's an x on both sides. If this is the first you've seen of me doing this, you can go back to the previous videos. If you're reasonably confident with equations, you could probably start it here and then see what happens afterwards. Looking at what's happening here, I'm trying to resist the thing we do as maths teachers where we just make it harder and more complicated. And one of the things I preach all the time is don't go too hard too quick. Make it a little bit different, but don't go crazy. But at the same time, some of the things on here are the typical things we do in an assessment that students were comfortable but would get these wrong. So let's have a look at why they get them wrong, see what's going on. There's an X on this side and there's an X on that side. So we don't want X's on both sides. We want the equation to say the answer is. So when we're solving equations, there is a number that will make this one true. There's a number that will make that one true. So each equation has one answer. Real life, we're doing this for everything you can possibly think of. Mind you, a lot of people won't use it in life, but there'll be a lot of people that do, depending on what you do for your job. Of course, thinking of people like probably nurses don't use it, hairdressers don't use it, people labouring in shops or factories don't use it, but there's plenty of people that do. So it depends on what you need. Let's have a look. I don't want X's on both sides. I prefer to talk about getting the X's on the left-hand side. Doesn't matter if you go right-hand side, but let's stick to the same as I've been saying in all the previous. We don't want this minus 4x here. So I talk about the opposites to both sides, the obs. So if I want the opposite of minus 4x, it's a plus 4x. Now have a look at what we're doing. We want to get rid of all of the minus and the 4 and the x in one go. So they're all married together as a group, they're multiplied together, they're connected together. So I can get rid of more than just say a minus 4. And in this case I can't get rid of just that minus 4. I could if I did a division. But once you divide, you're getting fractions and it makes it more complicated. So if I add 4x to that side of the equation, then I've got to add 4x to this side of the equation to balance the two of them up like a set of scales. So if I add 4x there, I add 4x here. Now, people come with problems all the time when we come to fractions and we get to negatives. So here we've got a negative which mucks up a lot of people. It's still got this 1 here. It can't just disappear. Now look at what's happening here. It's a minus 2 plus a 4. Let's forget about the x's for a moment. It's a minus 2. So if I started here at minus 2, I'm going to add 4. So adding 4 means up 4. So I go up 1, I go up 2, I go up 3, and I go up 4. So if I start at minus 2 and I go up 4, I get 2. If these were x's, I could have x's all the way through here. And I've got minus 2x, and I go up 4 positions, 1, 2, 3, 4, and I end up at 2x. So the interesting thing is this now becomes a plus 2x. So we've added more than what we had gone down. So as we go up, we end up with a positive 2x, not a minus 2x. Now, a minus 4x, let's go to 7 first. If I set this in reverse, it's just 4x take 4x. And most people then would just go, well, anything take itself would be 0. So 4x take 4x would be 0. So I don't need to write that minus because it would be minus 0. So what we've done is made that look in a simpler form. Maybe some people won't think simpler at this stage, but we've gotten rid of that 4x from that side, and it had an effect on this side, and it changed what we had over here. Now the one at the front is really a positive one. How do I get rid of a positive one? If I subtract 1 from this side, I subtract 1 from that side. Still like to talk about that we could have gone divide 2, divide 2, divide 2. But over the years, see so many students who try that and get in a mess. So I still prefer to say to people that 1 is all by itself. It's easier to remove a 1 than it is to remove a times by 2. So if we leave the times by 2 to last, it does tend to have less problems. So the 1 take the 1 is gone, so I'm left with just a 2x. The 7 take the 1 is just a 6. A lot of people could look at that and go 2, what's a 6? And you could just write down 3. If I wanted to get rid of a times by 2, if I wasn't confident, I could go divide 2 on the left, opposites to both sides, do the same on the other side. How many times does 2 fit into 6? It's 3. So same process here, but this one's got a number missing. So it looks a bit different, but it's not really. We still have the problem that we want to get rid of the 5x from the right hand side. So the question says the answer is. So before I can get to that, I need to get both lots of x's on the one side. So if I want to get rid of this 5x, I go subtract 5x from that right hand side, then I've got to also subtract 5x from the left hand side. And I haven't said it for a while, but I prefer to write them up here. Some teachers will prefer to put that as an extra line of working out in the bottom. My teacher did when I was at school. I still prefer that way. So 3x take 5x, we've taken away more than what we had. We go back to negative numbers, we end up with minus 2x plus 1. Now the 5x take 5x, people get a bit stuck there, but it's gone. When I say gone, 5x take 5x is 0. So if I wrote over here 5x take 5x, we actually get 0. So it's a bit of a weird looking equation, which I did on purpose, because now you've got a 0 and you've got some negatives. So let's follow the rules and not get tied down with it. If I get rid of the plus 1, it's easier usually. So if I go get rid of a plus 1, I go minus 1 to that side, minus 1 to that side. It's the opposite of a plus 1 is a minus 1. And you've got minus 2x equals minus 1. Then you've got this little trick here. What controls the minus 2 and multiplication? What's the opposite of multiplication? I divide this side by minus 2, I divide that side by minus 2. If I wanted to, by the way, when they were both minus, I could have turned them both into plus. But for the moment, let's just stick with doing this. How many times does minus 2 go into minus 2? It goes in once. It's one of the reasons you can see that two negatives make a positive, because anything divided by itself has to go in once. Don't have to write the 1, can if you want to. Two negatives will make a positive, and 1 over 2 is just a half. I see over the years a lot of people will talk about 1 over 2 when we're just talking about a half. So look at what the common terminology is. 1 over 2 is just a half, and it's really interesting to see who has trouble with that over time. Look at these two here. What have I done different again? I've got brackets involved. So you think, yeah, I'm okay, I'm good at this, and then you walk into a test and they do something that looks, again, weird or different. First thing in maths with the brackets, if you want to deal with this plus 2 here, we've got to expand the brackets out. So that 4 there means we've got 4 of everything in the brackets. So we've got 4 of the x, and we've also got 4 of the 2. So I've got a 4x, 4 2s are 8, plus 3 equals x. And I nag about get rid of that x first. But if you look at this, you have got a 4x plus 11 equals x. Could do that. If you wanted to, you could have gone like this first. You could have gone take x to get rid of the x on the right hand side, so I've only got it on the left. Don't have to get rid of it from the right, you could get rid of it from the left. But let's stick to the one thing. I take x from the right hand side, I take x from the left hand side. 4x take x is just 3x, so it's actually 4x take 1x, which is 3x. Still like to talk about, if x turned out to be 10, that would be 4 10s minus 1 10 would be 3 10s. If it was 5, I'd have 4 5s minus 1 5 would be 3 5s. So what we're saying is we don't know what the number is. We need to solve the problem, which is real life. We're solving problems everywhere all the time. So 4x take x is a 3x. So it's really like it's 4x take 1x is 3x. Don't forget to put the x's in. The 8 plus the 3 is an 11. And the x take the x is 0. So we're getting this 0 over here again. I'm nagging about it a little bit. Now, I could go divide 3, divide 3, divide 3. What's the problem with that system? Then I end up with this fraction here, which mucks up more people than what it's probably worth. So I still want you to see that we can go divide, but it's quicker if we, oh no, students have less problems if we go minus 11, minus 11. It's just those little things that you observe when you see a lot of students. So that's a 3x, 11 take 11, 0. 0 take 11 is minus 11. Last step, between 3 and the x's are times. I keep saying the same thing over and over again. If I divide this side by 3, I divide that side by 3. Now, 3 into 3 goes once, you don't have to write the 1. Now, you can leave it as a minus 11 on 3 in most places, especially Year 12 exams. Don't normally have people take marks off for doing that. Or, instead, you could say, how many times does 3 fit into 11? You go 3, 6, 9, so it fits in 3 times, and there's 2 left over. Now, if we start with thirds, we end with thirds. So we went 3 into that, goes 3 times, and then we have 2 left over. And don't remember if it was a minus to start with, it's a minus to finish with. Getting a bit long, but let's go through this one quickly. That's a 5x. 2 of that is 2x. 2 of that is 6. Now it's a bit different to all. I'm talking about x's on both sides, but I deliberately put this one. It's not x's on both sides. The x's on the same side. So you've got a 7x plus a 6 equals 7. Just collecting like terms. You're still going to keep the x's, 5 of those and 2 of those are 7 of those. Now you're back to the really simple ones. How do I get rid of plus 6? If I minus 6 this side and minus 6 that side, then I'm left with just 7x equals 1. So what have I got between the 7 and the x of time? So if I divide this side by 7, I divide that side by 7. Same thing I keep saying, 7 into 7 goes once, I don't have to write the 1, so it's 1x equals 1/7. So the answer to that one's 1/7. And again, now if you start looking at these, it's pretty hard to guess what the answer would be. You've seen some of the twists that take place. Thank you. Hi everyone, here's the fourth of the videos in the second playlist. Each of these questions look like they've only got, well these two look like they've only got the x written once, but each time they've got the x on the denominator of a fraction. So when I want to do something to any equation anywhere, anytime, I'm going to do the opposites to both sides. Keep on talking about the obs. So what you do to one side of the equation, you've got to do to the other side of the equation to get the equation to balance. So if I want to get rid of a divided by x, I often have this thing I talk about called equals of times 1. This one stands for fractions. And one of the biggest things in maths that people struggle with is fractions. So usually I say to people, get rid of fractions first. If I'm marking a lot of students at a fairly high level and it's got a fraction in the equation and I get, say, 30 students and you get 20 students who don't get rid of the fraction first, a lot of them get the question wrong. But the ones who get rid of the fractions first usually get the question right. It's just one of those things you see when you do lots of marking. So I say to people, how do I get rid of a divide by x? I times this one by x. If I times this term by x, I've also got to times that term by x. Student after student after student will have written here times by x, and they think they've balanced up the equation. But they haven't balanced up the equation because they've ignored this 3 here. It's like neglecting the 3 and thinking it doesn't matter. Like, hello, it's sitting there, it's there in the middle of everything. I times this one by x, I times this one by x, and I times that one by x. And then what happens? Any numerator can cancel out with any denominator when they're either straight above each other or you're multiplying. So in multiplying, we can cancel tops with bottoms. So I cancel that top with that bottom, and I'm left with just 2. So what happens really is I've gone x into x goes once, and x into x goes once, and I've really got 2 times 1 divided by 1. So there's the 2 times 1 divided by 1, which is just 2. So I just think of crossing out the x's and you're left with 2. This becomes a 3x, and that becomes a 5x. So it's really now like we're doing in the first 3 videos, that we've ended up with an x on the left hand side and an x on the right hand side. And either way, in that situation, we can go get rid of this 3x or we can get rid of the 5x. So yeah, I'm going to get rid of this 5x first. Because I'm talking about creatures of habit. If I remove 5x from this side, I remove 5x from that side. Again, we're balancing up the scales, and I'm left with 2, and I'm taking away more than what I had, so that's a minus 2x, and that's gone equals 0. And now I'm back to a fairly simple equation, though it mucks up a lot of people. A lot of people think plus 2, this is minus 2 to this side, and minus 2 to that side. Remember, we're not doing index laws, we're just getting rid of it. I'm writing it here to save some working out. So then I'm left with a minus 2x equals minus 2. And then if I want to get rid of that minus 2, I've got to multiply here. How do I get rid of a multiply by minus 2? I divide by minus 2. If I do it to the left hand side, I do it to the right hand side. Anything divided by the same thing, how many times does minus 2 fit into minus 2? And that's once. So the answer is actually 1, and look what happens over here. Anything again divided by itself is 1. I don't have to write the 1x, I can just write that as x. So a lot of people put an arrow of running out of room, and I can just go to x equals 1. I'd like to start the same question again though. And let's do it in a completely different manner. Get rid of that, and that's an x there. What if instead I knew that I can get rid of that plus 3 first, and in a lot of previous videos I talk about get rid of the 3 first. If I subtract 3 from that side, I subtract 3 from this side, and then I'm left with just 2 on x, because that's gone, 0, so I like to say gone, equals 2. And now I've got a much different equation I can solve. And again, there's so many things that you can do depending on what you prefer. What I'm going to show you at the moment is if this is just a fraction, I can turn it upside down. So all I'm doing is turning that upside down. So the x was on the denominator, now it's on the numerator. So if I turn this one upside down, I can turn that one upside down. And the upside down of 2 is a half. Then what can I do? I can then say, I'm going to get rid of a divide by 2, I can go times 2. And if I get any teachers watching this, there are so many choices of what I would do and what I prefer. So 2 into 2 goes once, numerator with a denominator. So that's a 1x, I don't have to write the 1, I can put the x, and the half times 2 is just 1. Yeah, different approach, some people prefer that. If I took that approach on question 2, I'd go take 5 here, I'd take 5 here. So this is the easy part to remove because it's just a 5 sitting there by itself. That's gone, I'm left with 4 on x, and I got 2 take 5 as minus 3. And you could try to think through what that actually means and shortcut, but again, it's just not worth it. If I turn this one upside down, I turn this one upside down, and the upside down of 3, by the way, that's 3 over 1, is a third, and we still have the minus sign there. Bit more complicated. If I multiply this side by 4 and multiply that side by 4, and then the 4's cancel out, they're actually 4 into 4 goes 1, so that's just x. And then what's really happening here, be careful, we've really got a 4 on 1, multiply the tops and multiply the bottoms. 1 times 4 is 4, 3 times 1 is 3, and it's minus 4 on 3. And of course, I could turn that into minus 1 and a third. Could go decimals, but more of a problem if you go to decimals. This one here, yeah, if we approach it like those ones, I could go take 1, take 1. But this is where I really prefer this system. If I times this one by x, I times that one by x, and I times this one by x, and I times that one by x. And let's have a look what's happened to the equation. The x's, I'm not going to keep nagging about all the details, they just cancel out. You can go back to previous videos if you've not seen me teaching these before. So that's just a 5, that's just a 1x, which is just an x. The x's cancel, that's just a 3, and that's 4 times x is just 4x. And we've got the equation with the x's on both sides, which is what I was talking about in the first place. Creatures of habit, I can go take 4x, take 4x. If I wanted to, I could go take x. But for today, I'm going to go take 4x on this side, I take 4x on that side, and I'm left with a 5. Now this is taken away more than what you had, that's minus 3x. And now that's gone. I do like to think of it as gone. It's actually 0, and that's 3. So now I can get rid of the 5. It's minus 5 from the left hand side and minus 5 from the right hand side. And I'm left with this minus 3x. Have seen many students over the years forget to put that minus in. It's like they just ignore it exists, or they think it's gone somehow. What's between the minus 3 and the x? There's a multiply, opposites of both sides. So if I divide this side by minus 3, I divide that side by minus 3, and then again, 2 ways to think about it. I could just cross them out and say they're gone. They're not gone, they actually become 1. So how many times does minus 3 go into minus 3 to 1? So that's 1x. So I've got 1x. And here's a bit of a twist. Those 2 negatives, keep talking about 2 negatives make a positive. Marking year 12 exams and tests and assessments. It's amazing still how often students muck up with negatives. That 2 negatives make a positive when you're multiplying. So when you're dividing, 2 negatives also make a positive. So I've got just x is 2/3. And we've got enough on that. I hope it helps. Hi everyone, more of these equations. We've got x on both sides, well I'm going to call number 5, and I put the big issue of and fractions. One of the rules I keep saying to people is get rid of fractions first. So many people struggle with fractions, so let's just get rid of the fractions first. By the way, this is a divide by 2, and how can I get rid of a divide by 2? The opposites to both sides. The opposite of divide by 2 is times by 2. So, I'm going to talk about it first. I could times this by 2, and that one by 2, and that one by 2, and that one by 2. By the way, there's 4 terms there. Everything gets separated by a plus or a minus is a term, and also there's 2 terms on this side of the equals and 2 on that side. So there's actually 4 terms. So when I multiply, everything gets multiplied. I have seen, I said years ago, I had one student would get this like this, write a bracket around the whole lot and multiply everything by 2 like that. Some people like it. Just have it as a mention. If you'd like to do that way, that's okay. If not, let's go back to this. If I multiply this one by 2, I multiply that by 2. Now this is the long way to do it, but I'm going to do it on purpose. If I multiply that one by 2, by the way, I make that look like a numerator and that by a denominator. The top and the bottom. If I multiply that one by 2, I multiply this one by 2, and everything has to be multiplied 2. I just can't ignore that 3, I can't just ignore the 1, I've got to multiply everything. Let's see what we've got. 2 over 2 is 1, so I can cross them off, they become 1. Not that they become nothing, they actually become 1. So let's have a look at what we've got. They cross out, and I'm left with just the x. I could say 1x, 3 2s are 6. This one is 2x on 3, which is a bit annoying. So numerator is 2x, and there's your 3 on the bottom. And the 2 1s are 2. And you go, oh my goodness, I've still got fractions. I've got to get rid of that fraction still. So this time, instead of multiplying by 2, I'm going to multiply by 3. It's a divide by 3, the opposite is times by 3. I multiply this one by 3. Just remember, I'm going to multiply all of them by 3. Can't just ignore the 2, it's also there. Multiply it by 3, and what have I got now? I've got a 3x, and I've got an 18. The 3's cancel, and I've still got that 2x left there. So there's your 2x, and there's the 6. Let's have a look at what we've got now. I don't want the x's on both sides. I want it to say to me the answer is. I want the equation to tell me the answer. This is called making x the subject. When I was a child, you used to have to put x on the left. Really mathematically you should, but a lot of people don't worry if you put it on the other side. So, I don't want x's on both sides. If I wanted to go take 18, I could. If I wanted to do everything and shortcut, lots of things we can do, but at the moment, I'm sticking to one method. I don't want x's on both sides. I only want it on the left-hand side, so I'm going to get rid of that 2x. If I take 2x from that side, I take 2x from this side. So 3x take 2x is 1x, I can just write x plus 18. 2x take 2x is gone, and I'm left with a 6. Now, a bit hard to guess that. Some people will look at it and just know what the answer is. Want to get rid of a plus 18, opposites to both sides. If I minus 18 from this side, I minus 18 from that side. What am I left with? I took away more than what I had, so that's minus 12. So the question tells you the answer. I could put it back in there and do that. So what we did first was multiply by 2. Then we multiplied by 3. So on this question, get rid of 2 fractions. I can multiply by 2 and then multiply by 5, but this time I'm going to do it all in one go. So if I multiply by 10, the 10 will cancel out the 2 as well as it will cancel out the 5. So this is nice because it saves a bit of extra working out. So 2 and 5 will both fit into 10. So actually we can talk about the lowest common multiple of 2 and 5. Some people will just think of 2 5s are 10, and that works. Sometimes it's a bit trickier, but for the moment it'll do the job. If I multiply that one by 10, I can't ignore the minus 10s. Don't neglect it. I multiply this one by 10, and I multiply, can't neglect the 1, it gets multiplied. So what we multiply one side by 10, everything on this side gets multiplied by 10 as well as everything on that side. And there's people who teach it with brackets and all sorts of ideas. How many times does 2 go into 10? Well, 10 divided by 2 is 5, so I can just write that as a 5x. So 2 into 10 goes 5. I could put x5, but everyone writes the numbers first. 3 tens are 30. It's got a subtraction. How many times does 5 go into 10? Twice. So that's 2 x's, and we've got a 10. So it's nice to do it all in one go. It certainly is better in the long run. Now, creature of habit, talk about our habits. Could get rid of 2x if you're confident. You could do the other way. You can do whatever you want. There's lots of things. But please, watch out for all the traps. You might notice, well, I'm going to get sidetracked here for a second. I'm not going equals, 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 equals. All these equals are extra. You'll never see a math teacher write it down there for an equation. We'll use it for algebra and expressions, but not for solving equations. On the solving equations, there's all your equals down the middle. They don't have to be beautifully lined up, but they go down the middle. And by the way, if you keep working down the page, when I compare a whole lot of students and some kept going across the page and they wrote all sorts of extra stuff, that will usually go wrong, or they write something that's actually mathematically incorrect. So keeping down the page, one of the things is it's easier for your eyes to go from there to there, there to there, there to there, there to there. There's something about what we call tracking with your eyes, that this is the easiest and quickest ways to go down the page. It usually reduces people's errors. So I want to get rid of the 2x on the right hand side. So if I take 2x from the right, I take 2x from the left to balance it up. And now it's really easy. We've got 3x take 30 equals, they're gone. Don't have to cross them off, don't have to show anything. You can just write that down. Now we want the x by itself, so we're going to get rid of the 3, get rid of the minus 30. You can go divide 3, divide 3, divide 3. It just adds an extra little step in the working. On this one I can go plus 30, the opposite of minus 30, plus 30. By the way, 30 take 30 is 0. So again, that's gone. I'm left with 3x equals 40. And you can see you can start getting some pretty revolting answers. But in real life you do. So what's in between the 3 and the x? There's the times. So the opposite of times 3 is divide 3. And if you haven't seen me talk about before, the quickest way to write divide 3 is that way. Just means divide. And 3 into 3 is 1, so that's a 1x. 3 into 40 is actually the answer of 40 on 3. Of course you can go 3 into 40, 3 into 4 goes once and 1 left over. 3 into 10 is 3, and you've got the old remainder of 1. So there's your remainder of 1. We started with thirds, we end up with thirds. So of course you could write 13 to the third if you wanted to. Could talk about decimals for a moment. If you wrote 13.3 repeater, no one's going to take the mark off you. If you wrote 13.3, most of the time you'll lose the mark because you've lost a whole lot of accuracy. You're just going to chop off the others. If the question said, write your answer correct to 1 decimal place, that's okay. If the question said, write it to 2 decimal places, then you go 13.33. Hi everyone, welcome back. I want to go to more equations that are really common that you'll see at high level, year 10, year 11 and 12. Without going crazy, talk about crazies. Let's have a look at these equations here. I could try to guess what number when I divide it by 3 plus that same number divided by 4 equals 5, and that would be just ridiculous. Take forever to do it. I have this thing I always talk about, get rid of fractions first. When I see lots of students, those who get rid of fractions first make less mistakes, have less problems and understand better. So my classes, I nag and nag, get rid of fractions first. So how do I get rid of a divide by 3? I multiply by 3. So if I multiply this one by 3, I'm going to multiply that one by 3, and I've got to multiply that one by 3. And I've had many students who have to do that step by step. I'm tempted to go through and go times 3, times 3, times 3. But I'm going to give it a go that it's quicker and easier, and I usually find less problems for the students, is if instead of times out all by 3, they times it all by 12. So you're looking for the lowest common multiple of 3 and 4, which is 12. A lot of students will just go 3 4s are 12. A bit different on this one, but you can. Let's have a look at it. So if I times this one by 12, I times that one by 12, and I times that. And what do I mean by 1? This is a term separated from another algebraic term with an addition, and an equal sign puts this term on the other side. Let's have a look at what happens. Denominator, numerator, 3 into 12 goes 4. So you can simply go 3 into 12. I used to go cross out the 3 and put a 4 there. Sometimes that's better when the numbers are worse, which you'll probably see over here. So then I'm left with a 4x, and 4 into 4 goes once, put it on once there. 4 into 12 goes 3, and I'm left with a 3x. Now, I could reteach this video in so many different ways, but that's the way for the moment. Let's have a look at what happened. Turn the yucky question into a really, really, really simple 7x equals 60. Of course, if I divide this side by 7, I divide that side by 7, and the answer is 60 on 7. Now, in Western Australia, if it was a waste question, you can just leave it at 67. If it's, you might have a maths teacher that says you must change it back to a mixed fraction, and then you've got to go how many 7s? 7 8s are 56. 7 into 60 is 7 8s are 56 and 4 left over. So you can do that and change it back to that, or even to a decimal. But when you're using 7, they're horrible decimals. Let's have a look at this one. I could multiply that by 4, multiply that by 4, multiply that by 4. Could multiply that by 6, could multiply that by 6, multiply that by 6. And some people are watching are screaming out going, multiplying by 24. But there's a better one than 24. And 24 gets too big. 4 and 12 both fit into 6. I do this sometimes, pick the bigger number, double it. And sometimes I go triple it or whatever, quadruple it. And I go, does 4 fit into 12? And the answer is yes. So pick the bigger number, you go double it, and you go, oh, look at that, the 4 fits into it. By the way, if I went 4 6s are 24, I could multiply everything by 24. So that's another way you can do it, is just multiply that. Think about the fact that 4 6s are 24. Let's have a look what's going on. I'm going to multiply at the front this time. I'm going to multiply by 12. It makes life a bit easier. So I put that 12 there, it gets a bit confusing. 12 there and 12 there. So if I multiply one term, I've got to multiply all the terms by 12. So now have a look at what happens. This is where I've got to slow down. 4 into 4 goes once, it's a denominator. 4 into 12 goes 3, and that's a numerator. Now what am I left with? 3 3s are 9 with an x. Now I do have students who don't like to cancel there. They'll say 12 3s are 36. 12 3s are 36 divided by 4 is 9. It's up to you. I prefer to cancel, it's up to you. What I've seen over the years, so you could go here 12 5s are 60, divided by 6 is 10. Whereas I go 6 and a 6 is 1, 6 and a 12 is 2. Especially when the numbers are revolting. 2 5s are 10, so I've got minus 10x. And then I go 3 12s are 36. And just like over here, I turned a fairly revolting question into a really simple one. So I've got minus x is 36. Now, how do you get rid of that minus? You can't end up with a minus, we want x equals. Now, we'll show you properly what happens here. If I multiply this side by -1, I have to multiply that side by -1. What do 2 negatives make? A positive. So therefore you've got an x or a 1x. And that becomes a negative. So what do I do instead of thinking about that? I just go turn that into a positive and turn that into a negative. I hope it helps. I think I've got one more to go. A bit more level of difficulty without going too crazy. Thanks for watching. If you're enjoying it, if you want to support me, press like and subscribe and tell your friends. Thank you.